Welcome to the gym. So what I'd like to do is show you how to graph the cosine graph when we have a change in the amplitude. Now, basically, when you look at the cosine graph, we have y equals cosine of x. And what I did is I graphed the initial period. And basically, the initial period is starting from 0 and going out one period where if you were to continue the graph, either in the positive or in the negative direction, the graph would repeat itself, that exact same graph. So it's going to repeat over and over and over again. So that's what we call the initial period. Now, just when the parent graph, the cosine, the reason why I call it the parent graph is because there's no transformations. It's just the function cosine of x. However, if we introduce y equals a cosine of x, a is going to actually represent the amplitude. And what the amplitude represents is the half distance between the maximum point and the minimum point of your graph. So you can see here, you can see the maximum point of my graph is at 1. The minimum point of my graph is at -1. The half distance, so the distance between 1 and -1 is 2. The half distance of that is 1, okay? And a lot of students say, well, however high or low that is, that's the amplitude. Well, when the graph starts at 0, or when 0 is, the middle at the x-axis, then yes, that's true. But when we have some transformations, that's not always going to be the case. Okay, so first thing we're going to do is determine the amplitude. And since these don't have any transformations, though,
Ms. Magloff, please call the main office. Ms. Magloff, please call the main office.
So whatever my amplitude is, that is how high that I am going to go on my graph. So the amplitude is the absolute value of a. Well, a in this case is 2. So the absolute value of 2 is just going to equal 2. So I'm going to graph this. So when I go ahead and graph, I'm going to complete the exact same graph. I'm not shifting or doing anything else. But now, instead of the graph going up to 1 and down to -1, it's going to go up to 2 and down to -2. OK? So now the half distance is 2. That means the total distance between the top and the bottom has to be 4. Now, one thing you can notice, though, is that the period, the x scale, everything else is going to be exactly the same. And what I always ask my students to do is always to graph 2 full periods. So rather than using this initial period, which is kind of a big period, what I'm going to do is I am going to graph 2 full periods. So what I'm basically going to do is the only thing that really has changed is the period. Everything as far as the x scale and the only thing that's changed is the amplitude. The x scale and the period remains the same. So therefore, now here's the exact same graph. You can see the x scale is exactly the same. But now instead of starting at 1, I'm going to start at 2. It's going to cross at pi halves. It's going to go down at pi, cross at 3 halves, and then come up. OK? And there you go. Looks like the exact same graph. And now if I just continue that, all right, well, then this would be 5 pi over 2. This would be 6 pi over 2, which would be 3 pi. This would be 7 pi over 2, and this would be 4 pi. However, I can just continue, again, the exact same pattern. And boom, there you go. So there you go, ladies and gentlemen. That is how you graph when the amplitude is 2. Now let's go and take a look at, well, what about if the amplitude is -1/2? Now it's very important that we notice that the amplitude is the absolute value of a. So the absolute value of -1/2 is just equal to 1/2. That's very important because what I'm going to do is I'm going to graph one now. Instead of doing 2 periods to the right, I'm going to do a period to the right and a period to the left. Now, we already kind of know the x scale. The amplitude is the only thing that's changed. So instead of going up to 2 and down to -2, now I'm only going to go up to 1/2 and down to -1/2. Right? So I'm changing the scale a little bit if you haven't already noticed. Right? I made from 0 to 1 much larger than it was up here. And that's because these are different problems. However, the x scale and the period is going to remain the same. So this would still be 2 pi. That would still be pi. That would still be pi halves. And this would still be 3 pi over 2. Now, when doing 2 periods, if I do a period to the right and a period to the left, that means I'm going to do the exact same thing just to the other side, except now all the points are going to be negative. OK, so now what we're basically going to do is graph the exact same thing, but now instead of the graph starting at 2, it's now going to start at 1/2. Now, there is one thing I want to make sure you notice. There is that negative that is going to affect our graph. So what I'm going to do is I am just going to sketch this, forgetting about the negative for a second, and just sketching it how I would know the graph would look like. Boom, 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 boom. So the graph will look like this. Right? Well, now, what that negative 1/2 does, that negative 1/2 actually reflects the graph over the x-axis. So now, all of my points that were either above or below, that should actually be like that, were either below or above the x-axis. Now, these points need to be reflected. So what I'm going to do is now I'm going to reflect them all across or over the x-axis. So the points that are on the x-axis remain the same. And then, now, all I'm simply going to do OK? So there you go, ladies and gentlemen. Now you can see that the blue graph is a reflection. And the other important thing is when the period is, absolute value period is less than 1, the graph is vertically compressed. However, in the absolute value of the amplitude is larger than 1, you can see that it's vertically stretched. So there you go, ladies and gentlemen. That is how you graph your cosine graph with a change in amplitude. Thanks.